All right. Hello, everybody. Welcome to my presentation about how GitOps changes everything in CI/CD. My name is Ádám Sándor. I work for a company called Container Solutions. We're a cloud-native consultancy company. I work in the Amsterdam office, but actually we also have an office in Warsaw. You can find me on Twitter under Ádám Sándor with a 0 instead of the O because the other one was already taken. So let's start with some advertisement. We recently released a book about cloud-native transformations written by some of my colleagues. It is a really good resource on how to get your company to properly transform to a cloud-native way of developing and infrastructure management using higher level patterns instead of getting lost in the technologies of which Docker runtime versus the other. And if you want to get a bit of a peek into it, you can go to cnpatterns.org, where you actually all the patterns that are in the book are up on that website. But the book also contains a nice story to link them all together. So my story today begins with a large German enterprise company I've been working with recently. Large German enterprise companies had the problem that their release cycles took them about half a year, large monolithic applications, old school infrastructure management, everything slowing them down, and they started to feel that the clock is ticking before their competition will take them over. So they started looking at cloud computing as the solution. More agility, faster development, better infrastructure management, and so on. Mind you, when I say cloud computing in this context, I'm talking about building an internal cloud, not public cloud providers. It was actually OpenShift, a lot of OpenShift. And they also wanted to embrace microservices and Kubernetes, of course, in the form of OpenShift. And they invited us as consultants to help them execute this properly. First thing that where the discussion got tough was that we warned them that if they keep their current development processes, which are very heavy, lots of checkpoints, lots of release managers, and so on, making sure everything is perfect because you get something to production, this will result in building a distributed monolith instead of getting the benefits of a microservice application deployed to the cloud. But they said that, oh, what we are a large German enterprise company, and we have change management processes and compliance and auditing and all kinds of heavy security requirements. We can't just go and deploy to production whatever some developer happened to build right now. And they were right. So all these requirements are pretty hard to satisfy, and they are all very important. I'm not trying to hand wave them. And especially the compliance, where basically the laws are interpreted by the regulator and are interpreted by the internal compliance and so on. So it's a difficult process to include in your continuous delivery. So we had a brainstorm on still how to go from code to production in, let's say, a single day. And to be able to do that, first of all, we have to look at continuous delivery, a bit of a refresher. So the point of continuous delivery is to release, instead of having a large, difficult release, try to make small releases often, which means you have to have a smooth pipeline to that where each step is as automated as possible to go from releasing software to deploying it to production. If we look at the full picture of CI and CD, basically CI is the process to build the code, run unit tests, And eventually, if everything is all right, build a Docker image and push it to a registry. And that's the moment when the continuous delivery process kicks in. We deploy it to a test environment, we test it. If it's all right, then we deploy to a production environment. So test environment is similar to production, etc. We've all been there and tried to build such a process. It's much more difficult than it looks like from a picture like this. If we add Kubernetes into this picture, then not much changes actually. What Kubernetes does for us is makes those deployment steps very, very easy by using kubectl apply or Helm install, which is great. And we can either use different Kubernetes namespaces for our different environments or different Kubernetes clusters. If we zoom in a little bit of what's happening here. So on the left side, as input to this deployment process, we have YAML files describing our Kubernetes resources, most importantly, our deployment or stateful set, which contains the image version of the application that will be deployed. This is the thing that we most frequently update. We just keep deploying a new image. When kubectl apply gets called, it calls the Kubernetes API server, submits all these resources that we defined, and the Kubernetes controllers will make it happen that all these resources actually get physically created and the image gets downloaded and it gets started and so on. The really important part here is that all these YAML files are declarative configuration. There, it says declarative. So we don't care about, or we don't have to care about, most importantly, we don't have to care about what was the previous state of the cluster before we apply some new configuration to it. This is the magic of Kubernetes. By Kubernetes makes deployments so much easier. Declarative configuration applying is much easier than figuring out like, okay, this is already deployed, we need to update that, or maybe we don't need to do this, and so on. So we have, let's say, in our as input to our deployment, we have our YAML files. Cool. And now we get around to GitOps and the solution to all these compliance and audit requirements. GitOps is very simply in this picture. It's super simple. All we do is we put those YAML files into a Git repo on the left side. So from now on, we will run kubectl apply. We'll run our deployment process when those files change in Git. And this is great because we all know Git versions our files and so on, and we can hook up some some CD pipeline to it and do the apply or other tools we will talk about later, and just do the applying to the cluster. However, if we zoom out a little bit and look at the CI process on the left side, if we want to have a fully automated deployment from code all the way to, let's say, our test environment, our CI process changes a bit with Git sitting there in the middle. It will still build a Docker image and push it to the registry. However, after it's done with that, it will need to actually update this Git repo, because now the Git repo is actually separating the CI process from the CD process. It's all controlled through Git, and we'll have to implement some automatic committing, pull request creation and merging on our Git repo to have the CI process work with the new GitOps process. So Git will, why would we do this? Because Git will give us at this moment a history, a nice audit trail on what has happened to the environment. It can also do more. Now, once we want to have a more heavy release process for our production environment, you can have another Git repo that controls the production environment, where developers and, let's say, operations or release managers can collaborate in a technical manner, as opposed to using something like ServiceNow and creating tickets and sending emails and whatever. Basically, the development team can just create a pull request against the production Git repo, and then ops can review the pull request, see that the version of the application has changed, there is a new service introduced, whatever has changed, and they can merge that pull request. And once they do that, the deployment process immediately kicks in and applies the intended configuration to the cluster. And this is the power that Git gives us. It gives us all kinds of options on how to design processes, and this all happens on a Git repo, which everybody knows. Well, it's not always everybody knows, especially on the operations side. Sometimes people are new to Git, or release managers are new to Git, but it's not that hard to learn. And there is always a GUI that you can use to merge these pull requests. And it's a very, very lightweight process where you can choose what Git provider to use. You can choose how you do the applying. You can choose how you do your CI. You can all tie these things together, and you don't have to use some one heavyweight tool to implement this process. So yeah, once developers want to update the application, they change the deployment YAML. They change it the version to V2. Ops approves it, then the deployment changes on the cluster to app v2, and thus Kubernetes will download the app v2 container from the container registry. So what did we gain with this? Again, we have a change log. We know who made a change and why, because there are Git commit messages. We can have a change review process using the Git pull request process, which is a very powerful, well-implemented process. We can have user access control on these Git repos. And we have a central source of truth where we can always look to see what's the intended state of an environment. First, things get complicated when, let's say, the apply fails for some reason, or some service doesn't start up and the intended state doesn't match the real state. And GitOps has a bit of a hard time handling that. So that's all nice, but why do I say that GitOps changes everything in CI/CD? Once we zoom in even more and look at a company-wide view on what happens when GitOps happens, suddenly, in our case, the Git provider that we used was Bitbucket. There were actually multiple data centers running multiple Kubernetes of actually OpenShift clusters. Same thing, Kubernetes OpenShift. When I say them, you can just understand Kubernetes pretty much. So multiple data centers, multiple Kubernetes clusters, and all of these basically managed through Bitbucket, through a bunch of repositories in Bitbucket. CI pipelines pushing changes into Git repos, or manual changes being made to these Git repos, changes approved by operations on the Git repos, and then some kind of agent running on every single cluster hooked up to the right set of Git repositories, applying the changes whenever they happen. And when you look at this picture, you can see there is a major change that has happened because of GitOps. Because now basically Git has become your central release management thing in your enterprise. And this setup has worked really well for satisfying all the compliance requirements and everything, and still have a pretty smooth process. The only downside actually was that we ran into was that in the end we ended up with too many Git repos, and ops had a hard time finding there was so many pull requests over so many Git repos. But that is also part of the problem, is also the heavy-handed release processes and stuff. So there is optimization to do, but the general architecture is very solid. And there are all kinds of options to reduce the number of Git repos or do other things. Now, how does this synchronization happen? So you can see on all the clusters there is some kind of agent pulling changes from Bitbucket. First of all, one thing to mention here is that this is very good for security and networking, because we don't need to have a central Jenkins or something that has access to all kinds of data centers and Kubernetes and whatever. It's rather the other way around, with all the Kubernetes clusters, the agents on these Kubernetes clusters having access to the central Bitbucket. with this pool-based access is actually more easy to secure than the other way around if a central release management service would have access to all the Kubernetes environments. So how can we implement this synchronization? How can we implement this agent? One way is the most simple way, and actually how we did it, because all the other tools were pretty new and we didn't trust them, was just basically use a CI tool. We use Jenkins, and in that CI tool, you create a little pipeline script, and that pipeline script will get executed whenever the GitOps repo changes, and then it will run kubectl apply with the YAML files that were in the GitOps repo. Pretty simple. We did some templating on those YAML files before applying them, but because configuration management is another interesting problem that I unfortunately don't have time to go into today, but this is the simplest way, and you can see that this is not a bad way to implement GitOps. They will not lose that much compared to the more sophisticated tools that are out there. That also shows the power of GitOps, because basically we decompose the problem of CI and CD. That way both become kind of simpler. Second option is using Flux from Weaveworks, which was the first GitOps tool from the company who actually popularized GitOps. And Weaveworks Flux runs as a tiny agent on your Kubernetes cluster, actually in your Kubernetes namespace, and it's meant to synchronize one namespace to one GitOps repo. Most important, it can actually synchronize the whole cluster, but always to one single repository. So if you would have multiple repositories hooked up to different namespaces, you would run multiple instances of Flux. That kind of shows that Flux is a really simple, low-level tool. It just runs as a pod on your cluster and then synchronizes stuff to your namespaces. It also has the weird feature that if you manually change something in the namespace, it can sync that back to the Git repo, but please don't use that feature. That's a terrible idea. So Flux will do the thing that Jenkins did for us in the previous slide, which is kind of good because still, while Jenkins does the job and that those pipeline scripts are pretty simple, you still have to create a lot of those pipeline script instances, hook it up to different repos and so on. If you use Flux, all of this will be actually done with Kubernetes YAML files. So all the things that you would normally use for managing Kubernetes. The third option, the more heavyweight tool, is Argo Cd from Intuit. Intuit is a large enterprise company who has built their own tool and open sourced it. So Argo Cd is a bit similar to Flux. However, the difference is that you can see there is a single Argo Cd instance running on the cluster. So the single Argo Cd can hook up to many Git repos. It has a concept of projects, and the project has a Git repo and then has some assigned namespaces. So it can act as a central controller for the whole cluster, and it can even connect to other clusters. So whether if you say you don't really want that whole nice pool model, but you rather want a central component to connect everywhere, you can have Argo Cd do that. It can connect to external clusters also. And Argo Cd also has a nice UI, so you can like watch all your deployments happening in a UI, which is actually pretty sweet to have. Nice overview, especially for people who like monitoring and having an overview over everything, which is important, especially in an enterprise environment where lots of stuff is happening over lots of environments. And then the third, the heavyweight champion is Jenkins X from CloudBees, from the makers of Jenkins. Jenkins X has nothing to do with Jenkins. Jenkins X is actually a tool that connects and installs multiple tools and implements the whole CI/CD process with GitOps. It actually provisions your Git repos in GitHub, it creates the CI process using Tekton. Actually, internally, it's using Tekton for its pipelines. And then it also does the deployment part, the synchronizing part. So Jenkins X will be a whole thing on your cluster that implements all things around GitOps. So if you really don't want to be thinking about anything, then just put Jenkins X there, and you have a greenfield thing. You can just try to go just with Jenkins X. So yeah, without really diving into the details of Jenkins X and getting lost in that, let's just move on. So which Git provider should you use for your GitOps needs? Basically, all three I have tried and work perfectly. You need a well implemented pull request process, which Bitbucket, GitHub, and GitLab, they all have that. They're all fine. You can pick whichever you want for all the other reasons. GitOps doesn't really need to define your choice. How to get started with GitOps? I would recommend either starting very simple and using your own pipelines and just using kubectl apply from Jenkins or GitLab or GitHub Actions or whatever. Or a nice option is actually going with Jenkins X, which actually at the state where it is right now, with a lot of actually Jenkins X has this thing where it doesn't handle multi-tenancy very well, so it's really not suited for enterprise environments. It's more suited for simple, like one team will have their own Jenkins X, another team will have also their own Jenkins X. It would be really nice if they all could if just one Jenkins X could handle many teams, especially since it's a complex component already. But for starters, it's great. It's a bit hard to install, but once you get it up there, it configures everything in a beautiful GitOpsy way, and you can get actually our solution didn't use Jenkins X, but we were heavily inspired by Jenkins X when we implemented this GitOps solution for the large German enterprise company. So this is once more the big picture that we implemented. And I already mentioned that the only real problem with this was the proliferation of the Git repositories. So we actually spent then a pretty large amount of time implementing provisioning of the Git repos and provisioning of this pipeline inside this Jenkins here, and provisioning actually the team CI pipeline so that it could commit to this to the right GitOps repo on Bitbucket. So there was a lot of work around managing these Git repos. So I recommend trying to reduce the Git repos. Like, let's say one team's whole environment for one team would be in the single Git repo or stuff like that, or just using branches instead of separate Git repos for all kinds of things. There is options to do different there, and yeah, it can be a problem to have too many Git repos. So in the end, at the end of this story, large German enterprise company is a little bit closer to the clouds, and it's great. And hopefully their journey will continue on a good path. Finally, one more reminder of the Cloud Native Transformation book. Really check out cnpatterns.org. There's a lot of good stuff there, even without getting the book. And please check out also our events page. We have a lot of free events coming up. A really cool one on the 10th of September about chaos engineering. So please check out containersolutions.com/events. Finally, thank you very much. I see I was a bit quicker than usual, so there is more time for questions if you have any. And also check out the two. I actually just yesterday finished writing a blog post about GitOps, the bad and the ugly. So all the things that are not so great about GitOps, it's going to be a fun read after this talk. And if that makes you sad, then you can read my 11 reasons for adopting GitOps blog post to give back the nice positive vibe again. Thank you.